Okay, sorry I got cut off there. I went just a tiny little bit over 15 minutes. This is the last thing. So at this point, we've taken our expression here. We've cubed everything inside. So 2 cubed is 8. A to the third is 9. B to the fourth to the third is b to the 12th. Now, since I have a little more time here, the reason that if I'm looking at a to the 9th and I'm pulling out a to the 8th, that's because if I think about the square root of a to the 8th, remember that the square root is really just a fractional exponent. So and that's happening, a to the 8th, the square root of a to the 8th is the same thing as a to the 8 over 2, which is just a to the 4th power. So that's why I know a to the 8th is a perfect square, is because it's divisible by 2. So from here, I know the square root of 4 is 2. The square root of a to the 8th is a to the 4th. The square root of b to the 12th is b to the 6th. And then I've still got the square root of 2 and the square root of a, which I can put back together as the square root of 2a. And so I'd have all that stuff there. Now, you did way more with this last year than we are ever going to need to do this year, because we're going to focus way more on the applications of exponential functions and what they can model in real life, and then using logarithms to actually be able to mathematically solve problems that use exponential models. So you spent a lot more time on this last year. It does really come up in calculus, but we're not going to spend a ton of time on it this year. So if you're kind of worried about this, I wouldn't be too concerned about that all that much right now. One thing I will mention here is if we ended up having to simplify, for example, a cube root of something like a to the 8th, what I'd be looking for is anything as an exponent that's divisible by 3. And so a to the 8th I could rewrite as a to the 6th times a squared. And if I'm under a cube root, well, the cube root of a to the 6th, because 6 divided by 3 is 2, is a squared. And then the cube root of a squared here just stays under because I can't do that. So this part here is a squared, and then the square root of the cube root of a squared would stay under there. So finally, take a look. Here's what you're doing with your homework for the rest of the class period. It's a little bit longer than usual, but again, these are more it's kind of skill problems, making sure that you've up to where we need to be on these things. They are all odds. You need to check them in the back of the book. I am not going to be posting the answers up on the board on Tuesday. We can certainly go over a few at the beginning of the class, but these are for your own practice. The answers are there for you to check. So please make sure you're using that opportunity to make sure that you know how to do this, and then if you don't, that you're finding some time to either schedule an advisory or come in before or after school. Because after today, we are moving on to the interesting stuff and actually using some exponential functions to model some real-world situations. So have a great day, and I will see you all tomorrow.